Hello and welcome to Software Testing from Scratch. On behalf of Eduonix, my name's Richard Martin. This is Chapter 4, Non-Functional Testing, video number 3. So in this video we're going to be covering internationalization and localization, compatibility and portability, maintainability and supportability, testability, as well as disaster recovery and business continuity. So first of all, we have internationalization and localization. Microsoft defines internationalization as a combination of real Microsoft defines internationalization as a combination of world readiness and localization. They're both means of adapting your application depending on the location and native language of the user. It can affect many regional differences of a target market. Internationalization is the method in which an application can be adapted to various languages without engineering or on-the-fly code changes. Localization is the process of changing internationalized software for a specific region or language by adding locale specific components and translating text. Localization, which is potentially performed multiple times for different locations, uses the infrastructure or flexibility provided by internationalization, which is ideally only performed once or as an integral part of ongoing development. Compatibility. Great. It works on your laptop. What about the 10,000 other models out there? So ensure compatibility of the system, application, website built with various other objects such as other web browsers, hardware platforms, users in the case if it's very specific type of requirements such as a user that speaks a different language or is disabled, and of course operating systems. Portability. Portability testing is the process of testing an existing software component or application in a new environment. The test results, defined by individual needs of the system, are some measurement of how easily the component or application will be to integrate into the environment, and these results will then be compared to the software system non-functional requirements of portability for correctness. The levels of correctness are usually measured by the cost to adapt to the environment. So here we have testing application in a new environment, software designed to run on Macintosh, OS X and Windows operating systems, applications developed to be compatible with Google Android and Apple iOS devices, video games and other graphic intensive software intended to work with OpenGL and DirectX APIs, software that should be compatible with Google Chrome, Mozilla and Firefox browsers. That's going to be the big one. Not many people would expect the exact same application to run on Mac that runs on Windows. That's just ludicrous. However, if it's a web-based application, they're going to be pretty annoyed if they can't access a particular application on their Mac when they can on their Windows box. That's going to be the clincher for a lot of people. And maintainability. Maintainability testing should be specified in the terms of effort required to effect a change under each of the following categories. Corrective maintenance is correcting problems. The maintainability of a system can be measured in terms of the time taken to diagnose and fix problems identified within the system. Perfective maintenance, which not many people have heard of, is an enhancement. The maintainability of a system can also be measured in terms of the effort taken to make a required enhancement so that the system itself can be easily tested. This can be tested by recording the time taken to achieve a new piece of identifiable functionality, such as changes to a database, adding users, etc. A number of similar tests should be run on average times calculated. The outcome will be that it is possible to give an average effort required to implement specified functionality. This can be compared against a different target effort, and assessment can be made whether or not requirements are met or not. Adaptive maintenance changes to an environment, basically. The maintainability of a system can be measured in the way described above for effective maintainability testing. Adaptive maintenance can be doing that on the fly. It's trying to specify those particular jobs that you wouldn't necessarily get every day. And then preventative maintenance, actions to reduce future cost of maintenance. Supportability. Help desk notification on exceptional events would be something like network monitoring, supportability is how easy is your system supported and serviced. Help desk notifications of exceptional events is very handy. It's an automated alarm bell which will go to somebody who's hopefully looking at their emails 24 hours a day. They'll be able to see that there's a particular problem with your system. This can be anything from a particular disk getting full, or to notify you that a user has attempted to log in 15 times in the last minute and failed every time, which would suggest that they've probably got the caps lock key on. But anyway, network monitoring. Can your application be monitored over the network? If it can, that's fantastic. You're going to get a lot better response from members of the public if it's monitored, purely because you'll be able to identify any bottlenecks a lot quicker. You'll be able to get to the bottom of any issues a lot quicker as well, because you'll be able to replay faults. If you're monitoring the network, you can see how much traffic is going to your application at a particular time, so you can replicate it. And documentation. This is the bane of most people's life, because developers very rarely do any documentation at all. If they do, count yourself lucky. In the real world, an application shouldn't go from development to test without some kind of support and documentation explaining how it works, and it shouldn't go from QA into the real world without your user guides and your manuals to explain to the end users how the system works. Event logging and tracing. If something fails on your system, you're going to want to know why, and you're going to want to know when. Event logging should give you that. It should be able to give you enough detailed information, or maybe even debug information, to try and diagnose a particular problem. Next we have logging of a program state. That could be a procedure entry and exit, optionally with incoming and return variable values. It could be exception block entry, or any kind of option to do with a local state. Software upgrade. It's not a good idea to send some software out there that needs a developer to look at the system, to do a code change, to build things from source, etc. Of course, you don't want people to be seeing source code anyway. It needs to have an easily upgradable system. And next we have graceful degradation, which is where the product is designed to allow recovery from exceptional events without intervention by any technical support staff. Hardware replacement or upgrade planning, where the product is designed to allow efficient hardware upgrades with minimum computer system downtime, such as hot swappable, execution paths and or local and global variables should all be part of this graceful degradation process. If something's getting a bit tough, you don't want your system to completely fail. You want it to slow down a bit. You want it to say, yes, okay, I can't handle that many users. Now, testability, the ability in which a piece of software will respond to a given test. I really can't say much more than that, to be honest. How testable is your system? Is it something that you press a button and the system makes 20 decisions for you and gives you an end result? If it is, it's probably not going to be very testable. Also, you need to choose which tests you're going to perform very carefully. Some systems may not be able to be load tested, some systems may not be able to be penetration tested, and some may not at all be compatible for a mobile device. So before you do any kind of documentation, make sure you know what kind of tests you're going to perform in the first place. Now, disaster recovery and business continuity. I'll just go through the steps first anyway. Verify the success of a service restoration after a disaster. What happens to the workload if the system becomes unavailable? How long does recovery take? and how does the application cope with partial network failure. This type of testing is sometimes carried out in conjunction with load testing. Disaster recovery testing is much more realistic if the tests are carried out while the application is busy servicing user workload. Of course, not real users, because it wouldn't be a very good test if you decided to do a disaster recovery in the middle of the working day on a live system. After each test, use the detailed logs and schedules to identify any errors in your procedure, and of course eliminate them. You can then retest any changes and incorporate them into a recovery plan. After changing the recovery plan completely, you need to revise all your existing disaster recovery documents as well. Because if all the disaster recovery and business continuity information is just stored in your head, it's not very good if you leave the company. That all comes under terms of escrow and things as well, though. So make frequent tests early in the implementation of your disaster recovery plan. Once you've removed the major problems, you can test it less frequently. The frequency will depend on the interval between major changes, whether it be hardware or software, how current you want to keep your recovery plan, and how critical and sensitive your business processes are. The more critical they are, the more frequently tested they will have to be. Sometimes even clients will themselves specify how often you need to perform disaster recovery plans, how often you need to do vulnerability analysis, etc., etc. And of course, if you go down the certification route for hardware or software, they may want the software to be certified every kind of 6 months or something like that.